All right, the last video that I wanted to show you guys, and it's only 2 slides here, is for phase diagrams. And phase diagrams are a big deal because they show us um, what is going on, the transition points with any one substance as it goes from solid, liquid to gas. Okay, so what we see here famously is water vapor. Excuse me, is the phase diagram for water. And on the phase diagram, you'll notice a couple things. Let's take a look at the organization. First of all, pressures in atmospheres is increasing this way. Temperature in degrees Celsius is increasing this way. Okay. And now with water, we can recognize a couple things. I noticed that here is the boiling point of water. Here is the freezing point or melting point of water. Okay. And also here's 1 atmosphere. And I notice a few things. The point at which 1 atmosphere and 0 degrees Celsius hit is called my normal freezing point. Okay, so the NFP, or the normal freezing point, occurs at the temperature in which the temperature at which it hits when there is 1 atmosphere of pressure. Okay, for water, it's 0 degrees. The normal boiling point is 100 degrees because it's the point at which these lines intersect here. Okay, so the normal boiling point is 100 degrees at 1 atmosphere. The normal freezing point is 0 degrees at 1 atmosphere. Okay, now we see these lines everywhere. There's a line here, and a line up here, and a line up here. These points, any point along these lines, at any collection of data, in other words, whatever temperature I have here and whatever pressure I have here, that gives me the equilibrium where, at least along this line, where liquid water and water vapor, a gas, exist in equilibrium. So along these lines, there is equilibrium between liquid and gas. Along this line, there is an equilibrium between solid and liquid water. And along this line down here, I have an equilibrium between solid and vapor. So you notice that as this goes up this way, you'll notice that in order to keep something in equilibrium, I have to increase the temperature, but I have to also increase the pressure. I have to, while the particles want to move more down here, I have to squeeze them up higher up here. Now this continues for a while until I get to what's called the critical point. And the critical point is the temperature at which, it's the highest temperature at which no matter how much I increase the pressure, okay, so it's the temperature at which no matter how much I increase the pressure, I cannot get back down to a liquid. That's the critical point. So you kind of have this kind of hazy region where it's you're still in the water vapor phase. So that's why you kind of see this kind of keep trailing off in this direction. Okay. The last thing I want to talk about on the phase diagram is this, which is called the triple point. And the triple point is where I have solid, liquid, and gas, or ice, liquid water, and water vapor existing all at one point right there in the middle. And that is approximately a little bit above the normal freezing point and right below, and this isn't to scale, and it's below the normal, or at least atmospheric pressure of 1 atmosphere. Okay, so it's the point at which solid, liquid, and gas all exist at the same point. Okay, the last thing I want to say about this is because water has a solid which is less dense than its liquid, I see a negative slope on the ice to water equilibrium line here, a negative slope. All the other phase diagrams, because their ice is more dense than their liquid, I see a negative slope here, okay, but not liquid water. All right, let's move on to another one. Here, this is, I believe, carbon dioxide, and I'm guessing that because of the super low temperature here, let me see here. No, I'm sorry, I believe this is ethanol, something like that. It doesn't really matter, either ethanol. Okay, but what I do see right here, I see the normal, let's see here, oh, here's 1 atmosphere. So here is the, let's see, solid to gas, here is the normal freezing point, here's the triple point, and we have the same thing here. I see more of a positive slope because the solid is more dense than the liquid. Okay, here is the critical point here where I have the supercritical fluid. No matter how much more I raise the temp, it's the highest temperature at which no matter how much more I raise the pressure, I still can't get back down to a liquid. Okay, I believe that's it. Yes. So if you have any questions, email me tonight or some other time, but I'll upload this probably as a YouTube video so everyone can check that out. Good luck.